Disruptive Concepts, ChatGPT, Large Language Models, LLM, and the Future of Technology. Part 1, Introduction to Large Language Models. Chapter 1, What are Large Language Models? Large Language Models, LLMs, are a subset of artificial intelligence, AI, specifically in the field of natural language processing, NLP. These models are designed to understand and generate human-like text, bridging the gap between machines and human language. LLMs can perform a wide range of tasks, including translation, summarization, and question answering. They are trained on massive datasets, often comprising billions of words sourced from books, websites, and other texts. One popular LLM is GPT-4, standing for Generative Pre-trained Transformer 4, developed by OpenAI. GPT-4 has a staggering 175 billion machine learning parameters that help it understand context and produce relevant text. These models have found applications in various industries, from healthcare and finance to education and marketing. The primary goal of LLMs is to predict the next word in a given sequence of words, thereby generating coherent and contextually relevant text. They utilize algorithms and statistical methods to understand the nuances, idioms, and syntax of human language. Because of their complexity, LLMs require significant computational resources for both training and operation. Companies like Google, Facebook, and OpenAI are key players in the development and deployment of LLMs. They are often accessed via application programming interfaces, APIs, allowing businesses to integrate them into existing systems. The first generation of LLMs were relatively simple, but advancements in machine learning have led to more sophisticated models. LLMs are different from rule-based chatbots, which have a limited set of predefined responses. While rule-based models operate based on a fixed set of rules, LLMs learn from the data they are trained on. This training process involves feeding the model a large number of text sequences and adjusting its parameters based on the patterns it observes. They can even generate creative content like poetry, stories, and scripts, expanding their utility beyond business applications. However, LLMs are not without their challenges, including ethical concerns and computational costs. Alan Turing, a pioneering computer scientist, laid the groundwork for computational linguistics, which eventually led to the development of NLP and LLMs. Turing's Turing test is a measure of a machine's ability to exhibit intelligent behavior indistinguishable from that of a human, a test that modern LLMs are increasingly capable of passing. Chapter 2, History and Evolution. The history of LLMs is rooted in the broader history of AI and NLP, which began as early as the 1950s. In 1956, the Dartmouth Workshop, organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, marked the birth of AI as a field of study. Early NLP systems were rule-based and struggled with the complexities of human language. The shift from rule-based systems to machine learning models occurred in the late 1990s and early 2000s. This transition was driven by the availability of large datasets and advancements in computational power. In 2018, OpenAI released GPT, which had 110 million parameters, showing promise in generating human-like text. GPT-2, released in 2019, had 1.5 billion parameters and was initially deemed too dangerous to be released in full due to its potential for misuse. GPT-3, launched in 2020, took the world by storm with its 175 billion parameters and capabilities, offering services from automated writing to code generation. Each new generation of GPT has seen exponential growth in the number of parameters, enhancing their capabilities and accuracy. LLMs have also become more accessible, with cloud-based services offering these models as a service. The competitive landscape has grown, with companies like Google and Facebook developing their own versions of LLMs. As of 2030, the LLM market size is estimated to be worth $420 billion, according to Grand View Research. The sophistication of these models has also led to ethical and societal concerns, prompting research into responsible AI use. Machine learning pioneers like Geoffrey Hinton, Yann LeCun, and Yoshua Bengio have contributed to the algorithms that power these models. Fine-tuning, the process of adapting an LLM for a specific task, has also become a significant area of research and development. The democratization of LLMs is underway, with more open-source models becoming available for public use. Despite their complexity, LLMs are becoming more energy efficient, thanks to advancements in hardware and software optimization. The development of LLMs has been a collaborative effort involving academia, industry, and open-source communities. These models are now being integrated into everyday applications, from email clients to productivity tools. The speed at which LLMs are evolving suggests that their capabilities will continue to expand, impacting various aspects of society and business. Chapter 3: How do they work? Large language models operate based on neural networks, a type of machine learning algorithm inspired by the human brain. The primary component of these neural networks is a neuron, a mathematical function that processes input data. These neurons are organized into layers, and data flows through these layers during both training and inference. During training, the model adjusts its internal parameters to minimize the difference between its predictions and actual outcomes. The most common architecture for LLMs is the transformer model, introduced by researchers at Google in 2017. The transformer architecture excels in handling sequences of data, making it ideal for language-based tasks. In a process known as tokenization, the text data is broken down into smaller pieces, often words or subwords, which are then fed into the model. Each token is represented as a vector, a string of numbers that capture its semantic meaning. These vectors pass through multiple layers of the neural network, each layer adding complexity and understanding. The model's final layer produces a prediction, usually the next word or sequence of words, based on the input it received. One critical aspect of training LLMs is backpropagation, a technique used to adjust the model's parameters based on the error of its predictions. Backpropagation was popularized by Geoffrey Hinton, a key figure in the field of machine learning. The accuracy of an LLM is often measured using metrics like perplexity, which quantifies how well the model predicts a sample. Due to their complexity, training LLMs requires specialized hardware, usually graphics processing units, GPUs, or tensor processing units, TPUs. Once trained, these models can be deployed on servers or even edge devices, although the latter may require a simplified version due to computational constraints. Some LLMs are also capable of few-shot or zero-shot learning, where they can perform tasks even when provided with very few or no examples. This is achieved through a process known as transfer learning, where a model trained on one task is adapted for another. Transfer learning has been a significant advancement in machine learning, allowing for more efficient and versatile models. Companies often fine-tune pre-trained models on their own data to achieve better performance for specific tasks. Overall, the functioning of LLMs is a blend of intricate algorithms, large datasets, and powerful computational resources. Chapter 4: The basics of utilizing LLMs. To make LLMs accessible, companies usually provide them as a service through application programming interfaces, APIs. These APIs allow businesses to integrate the power of LLMs into their existing systems without needing expertise in machine learning. One popular example is OpenAI's GPT-3 API, which has been used in applications ranging from automated customer service to content generation. Through API calls, developers can send a prompt to the model and receive a generated response, which can then be used in various applications. The cost of using these APIs is often based on the number of tokens, words or subwords, processed. For more specialized needs, businesses can opt for fine-tuning, where the LLM is further trained on a specific dataset. Fine-tuning allows companies to adapt the general capabilities of an LLM to their unique requirements. However, fine-tuning usually requires a higher level of expertise and computational resources. Many cloud providers, like AWS, Azure and Google Cloud, offer machine learning services that include pre-trained LLMs. These cloud services often come with additional features like monitoring, logging, and scalability options. For those looking to experiment before committing, there are also free tiers and trial periods provided by many LLM services. Many open-source libraries, like Hugging Face's transformers, offer pre-trained models that can be fine-tuned and deployed. Security is a significant consideration, especially for businesses dealing with sensitive or confidential information. Data encryption and secure API endpoints are standard features provided by reputable LLM service providers. AI and healthcare have demonstrated how fine-tuned LLMs can be compliant with industry regulations like HIPAA. Businesses should also consider the latency and response times, as real-time applications may have specific requirements. An emerging trend is the use of LLMs on edge devices, although this often involves using a simplified version of the model due to hardware limitations. To evaluate the effectiveness of an LLM in a business application, key performance indicators, KPIs, like customer satisfaction or task completion rates are commonly used. The ongoing maintenance of an LLM integration involves regular updates and possibly retraining to adapt to changing needs. In summary, utilizing LLMs in a business context involves considerations ranging from technical and financial to ethical and regulatory. Chapter 5: Ethical Considerations. As LLMs become increasingly integrated into societal and business functions, ethical considerations become paramount. One primary concern is the potential for these models to generate misleading or harmful content. To address this, many LLM services include content filters and moderation features. However, no filter is perfect, and human oversight is often necessary to catch nuanced or context-specific issues. Discrimination and bias are significant concerns, as LLMs can inherit the biases present in their training data. This has led to ongoing research and development in the field of ethical AI, aiming to create more equitable and fair machine learning models. The misuse of LLMs for generating fake news or manipulating public opinion is another growing concern. Transparency in how these models are trained and what data is used can help mitigate some of these ethical challenges. Privacy is another issue, especially when LLMs are used in applications that handle sensitive or personal information. Companies like Apple are researching differential privacy, a technique that allows for data analysis while preserving user anonymity. Regulatory frameworks for the ethical use of AI and LLMs are still in their infancy but are a focus of ongoing legislative efforts. The European Union has proposed regulations that include strict requirements for high-risk AI systems, including certain uses of LLMs. Industry standards and ethical guidelines are also being developed by organizations like the Partnership on AI, which includes tech giants like Google and Facebook. Ethical considerations are not just the responsibility of the companies developing LLMs but also the businesses that deploy them. Consumer awareness and expectations regarding ethical AI are growing, adding market pressure for responsible practices. Several high-profile cases of AI misuse have led to public outcry and calls for stricter oversight. Tim Berners-Lee, the inventor of the World Wide Web, has emphasized the need for ethical considerations in the development and deployment of AI technologies. Ethical AI is a multidisciplinary field, involving contributions from computer science, social science, law, and ethics. As LLMs continue to evolve, the ethical landscape will also change, requiring ongoing vigilance and adaptability. In summary, the ethical use of LLMs is a complex but crucial aspect of their integration into business and society. Thanks for watching. Part 2, LLM Applications in Business. Chapter 1, Customer Service. Customer service is one of the most common applications for LLMs, providing 24/7 support to clients. According to a report by IBM, chatbots and automated customer service can reduce customer service costs by up to 30%. Businesses like Shopify and MasterCard have already implemented LLMs in their customer support systems. These models can handle queries, process refunds, and provide product recommendations without human intervention. Utilizing LLMs in customer service can dramatically increase response times, enhancing customer satisfaction. A study by Forrester Research found that 63% of customers are willing to return to a website that offers live chat support. Unlike human operators, LLMs can simultaneously handle multiple customer queries, thereby reducing wait times. They are also capable of multi-language support, making them ideal for global operations. If the model encounters a complex or sensitive issue, it can seamlessly transfer the query to a human agent. Companies like Zendesk offer LLM integrations that can be easily incorporated into existing customer service platforms. Metrics like Net Promoter Score, NPS, can be used to evaluate the effectiveness of LLM-based customer service. Fine-tuning the LLM on past customer interactions can make the system more accurate and context-aware. However, businesses must be transparent about the use of automated systems, as mandated by regulations in some jurisdictions. Security measures like data encryption are crucial when handling sensitive customer data. Customer feedback loops are important for continuously improving the performance of the LLM. With advancements in voice recognition, LLMs are also entering the domain of voice-based customer service. Ongoing training and updates are essential to keep the LLM abreast of new products or policies. Businesses should also have a contingency plan for technical glitches or outages. Customer service LLMs can be integrated with other business systems like inventory management to provide real-time information. Overall, LLMs offer a scalable, efficient, and cost-effective solution for customer service needs. Chapter 2, Content Creation. LLMs are becoming invaluable tools for generating written content, from marketing copy to technical documentation. Companies like Jasper AI and Copy.ai offer content creation services powered by LLMs. According to a survey by Content Marketing Institute, 60% of businesses lack a documented content strategy, an area where LLMs can assist. They can generate SEO-friendly articles, email campaigns, and even social media posts. LLMs can produce content in multiple languages, allowing for easy localization of marketing materials. For e-commerce businesses, LLMs can generate product descriptions and reviews, saving countless hours of manual effort. They can also assist in data journalism by analyzing and summarizing large datasets for articles or reports. Companies have utilized LLMs for automated news generation, particularly for topics like sports scores or financial earnings. However, the generated content should be reviewed for accuracy and compliance with editorial guidelines. Metrics like engagement rates and click-through rates, CENTER, can be used to measure the effectiveness of LLM-generated content. Automated content generation is especially useful for small businesses that may not have dedicated content teams. LLMs can also produce creative content like poems, stories, or even scripts for promotional videos. They are also capable of generating code, offering a valuable tool for software development. The fine-tuning of LLMs for specialized content, such as medical or legal documents, is an area of ongoing research. Businesses should be aware of ethical considerations, such as plagiarism or copyright infringement, when using LLMs for content creation. Companies like Grammarly use LLMs to provide real-time writing assistance, improving the quality of user-generated content. Given the rapid pace of content consumption, LLMs offer a scalable solution to meet the growing demand. Subscription-based models for LLM content services offer businesses flexibility and cost efficiency. The integration of LLMs with content management systems, CMS, allows for seamless publishing workflows. In summary, LLMs offer a versatile and efficient solution for various content creation needs in the business domain. Chapter 3: Data Analysis. Data analysis is a critical function in modern businesses, and LLMs offer a new dimension to this process. Traditional data analysis tools like spreadsheets and business intelligence by software can be augmented with LLM capabilities. Companies like ThoughtSpot are integrating natural language processing, NLP, to allow users to query data in everyday language. LLMs can sift through large datasets and generate summaries, trends, and insights in a human-readable format. According to IDC, the amount of global data will reach 175 zettabytes by 2025, making automated analysis essential. LLMs can also assist in sentiment analysis, gauging public opinion on products, services, or market conditions. For financial firms, LLMs can analyze news articles, reports, and social media to predict market trends. They can also generate automated reports, reducing the manual workload for data analysts. With advancements in machine learning, LLMs are becoming capable of more complex tasks like anomaly detection. By integrating LLMs with existing data platforms, businesses can create interactive dashboards that explain insights in natural language. However, the quality of analysis is highly dependent on the quality and accuracy of the input data. Security and privacy are significant concerns, especially when analyzing sensitive or confidential information. Companies like Salesforce have incorporated LLMs into their analytics platforms, offering advanced features like predictive analytics. LLMs can also assist in data visualization by suggesting the most effective ways to represent data graphically. They can be used in real-time analytics, providing instant insights during events like marketing campaigns or product launches. The fine-tuning of LLMs for industry-specific analysis, like healthcare or manufacturing, is an area of active research. Businesses should validate the insights generated by LLMs, as they are not immune to errors or biases present in the data. The integration of LLMs with other emerging technologies like IoT can offer even more comprehensive data analysis solutions. As LLM technology advances, we can expect more sophisticated analysis capabilities, including causal inference and multivariable analysis. Overall, LLMs offer a powerful tool for data analysis, capable of handling the scale and complexity of modern business data. Chapter 4: Recruitment. The recruitment process is often time-consuming and costly, but LLMs offer an efficient alternative. According to a study by the Society for Human Resource Management, the average cost to hire an employee is $4,129, with a timeline of 42 days. LLMs can automate the initial screening of resumes, filtering candidates based on specified criteria. They can also generate job descriptions and postings, ensuring they are optimized for visibility and relevance. Companies use AI and machine learning to match candidates' emotional and cognitive abilities with company profiles. LLMs can conduct initial interviews through chat or email, asking relevant questions and scoring candidates based on their responses. They can also assist in onboarding by providing new hires with necessary information and documentation. For remote positions, LLMs can evaluate candidates from different time zones without the limitations of human recruiters. However, human judgment remains crucial for assessing subjective factors like cultural fit or interpersonal skills. Businesses should be aware of the potential for algorithmic bias in LLMs, which could lead to discriminatory hiring practices. To measure the effectiveness of LLM-based recruitment, metrics like time to hire and quality of hire can be used. The fine-tuning of LLMs for specific industries or roles can improve their accuracy and effectiveness. Companies like LinkedIn are already incorporating LLM features in their recruitment tools, offering automated candidate matching. LLMs can also assist in internal recruitment, identifying suitable candidates for promotions or role changes. They can automate the collection and analysis of employee feedback, providing valuable insights into workplace satisfaction. GDPR and other data protection laws necessitate careful handling of personal data during the recruitment process. LLMs can also assist in crafting employer branding materials, helping companies attract top talent. By automating routine tasks, LLMs allow human recruiters to focus on more strategic and nuanced aspects of hiring. As technology evolves, LLMs could even assess candidates through simulations or interactive assessments. In summary, LLMs offer a comprehensive solution for automating various stages of the recruitment process, making it more efficient and data-driven. Chapter 5: Training and Development. Employee training and development are crucial for business success, and LLMs offer a modern approach to these traditional practices. According to the Association for Talent Development, companies that offer comprehensive training programs have 218% higher income per employee than those without. LLMs can create personalized training modules and materials based on an individual's role, experience, and learning pace. They can also generate quizzes, assessments, and simulations to evaluate employee comprehension and skills. Real-time feedback can be provided during training sessions, enhancing the learning experience. For global companies, LLMs can translate training materials into multiple languages, ensuring uniform training across different geographies. They can also adapt training programs to comply with industry-specific regulations and standards. Companies like Coursera and Udacity are already integrating LLMs to provide more interactive and personalized learning experiences. LLMs can also assist in leadership training by simulating different business scenarios and decision-making exercises. They can be integrated with learning management systems, LMS, to track progress and generate reports automatically. Key performance indicators, KPIs, like employee retention rates and performance metrics can be used to measure the impact of LLM-based training. LLMs can also assist in career development, offering personalized paths and resources for skill development. Gamification, the application of game design elements in training, can be enhanced using LLMs to create more engaging experiences. Data privacy is a concern, especially when training involves sensitive or proprietary information. Businesses should also consider the accessibility of LLM-based training, ensuring it's available to employees with disabilities. Continuous updates are essential to ensure that the training materials stay relevant and up to date. Companies like IBM are using LLMs for internal training, particularly in complex fields like cybersecurity and data science. The COVID-19 pandemic accelerated the adoption of online training, and LLMs offer a scalable solution for remote learning. As artificial intelligence, AI, and machine learning continue to evolve, the capabilities of LLMs in training and development will likely expand. In conclusion, LLMs provide a versatile, efficient, and personalized approach to employee training and development, offering significant advantages over traditional methods. Thanks for watching. Part 3: Industry-specific use cases of LLM. Chapter 1: Healthcare. Healthcare is an industry where the potential applications of LLMs are both diverse and impactful. According to a report by Frost & Sullivan, the healthcare AI market is expected to reach $6.6 billion by 2021. LLMs can assist healthcare professionals in diagnosing conditions by analyzing medical records and scientific literature. Companies are using LLMs to power virtual health consultations. They can also assist in administrative tasks, such as appointment scheduling and billing, improving operational efficiency. LLMs can assist in drug discovery by analyzing existing research and proposing new combinations or applications. They can help in generating patient reports, reducing the manual workload for healthcare providers. In radiology, LLMs can annotate images with preliminary findings, assisting radiologists in their assessments. Privacy is a significant concern, especially with regulations like the Health Insurance Portability and Accountability Act, HIPAA, in the United States. However, techniques like differential privacy can be employed to use patient data without compromising confidentiality. LLMs can also assist in mental health care by providing initial assessments and ongoing monitoring. Telemedicine, which has gained prominence due to the COVID-19 pandemic, can be further enhanced with LLM support. Biomedical research is another area where LLMs can accelerate progress by analyzing large datasets and generating hypotheses. They can also assist in epidemic tracking and response, providing real-time analysis of data from multiple sources. However, LLMs are not a substitute for professional medical advice and should be used in conjunction with human expertise. Medical ethics, including informed consent and equitable access, are crucial considerations in the healthcare application of LLMs. Dr. Eric Topol, a prominent figure in digital medicine, has advocated for the responsible use of AI in healthcare. Clinical trials involving LLMs must adhere to rigorous ethical and scientific standards. The pandemic has accelerated the adoption of digital health technologies, including LLMs, a trend likely to continue post-pandemic. Overall, LLMs offer a powerful tool for various healthcare applications, from diagnostics and treatment to research and administration. Chapter 2: Finance. The financial sector is another industry where LLMs are making significant inroads. According to the autonomous research firm, AI technologies could reduce operating costs across financial services by 22%. LLMs can analyze market trends, news, and social media to predict stock movements and trading opportunities. Automated chatbots can handle customer inquiries, process transactions, and even offer financial advice. They can assist in risk assessment by analyzing large datasets to predict loan defaults or fraud. Companies use LLMs to provide real-time analytics and insights to financial professionals. Compliance with financial regulations can be automated using LLMs, reducing the risk of costly legal issues. For asset management, LLMs can suggest portfolio adjustments based on market conditions and investment goals. Quantitative trading strategies can be developed and refined using LLM analysis of market data. However, the use of LLMs in finance raises ethical questions, including market manipulation and data privacy. Financial transactions often involve sensitive information, requiring robust security measures when using LLMs. LLMs can also assist in customer onboarding, automating tasks like identity verification and document submission. Warren Buffett, a legendary investor, has been cautious about the rapid adoption of technology in finance, cautioning against over-reliance on algorithms. Open banking APIs can be combined with LLMs to offer more personalized financial services. LLMs can also generate financial reports and summaries, streamlining the work of analysts and auditors. The role of human oversight in interpreting and acting on LLM-generated insights remains crucial in financial decisions. Blockchain technology, combined with LLMs, could offer new paradigms for secure and transparent financial operations. Ongoing training and updating are essential for financial LLMs to adapt to changing market conditions and regulations. The integration of LLMs with other financial software can create a seamless ecosystem for trading, risk management, and customer service. In summary, LLMs offer a range of applications in finance, from analytics and trading to customer service and compliance. Chapter 3: Retail and e-commerce. The retail and e-commerce sectors are increasingly adopting LLMs to enhance customer experience and operational efficiency. According to a report by Capgemini, AI could save retailers as much as $340 billion annually by 2022. LLMs can power recommendation engines, suggesting products based on customer behavior and preferences. They can assist in inventory management by analyzing sales data and predicting future demand. Chatbots can handle customer queries, process returns, and even assist in the checkout process. Companies like Amazon are using LLMs to improve search functionality, making it easier for customers to find what they're looking for. LLMs can generate product descriptions, reviews, and other content, saving time and resources. Personalized marketing campaigns can be designed using insights generated by LLMs, improving conversion rates. They can also assist in price optimization, analyzing market trends to set competitive prices. In physical stores, LLMs can be integrated with Internet of Things, IoT, devices for real-time monitoring and analytics. Customer feedback can be automatically analyzed to identify areas for improvement or potential new product ideas. For small business owners, LLMs offer an affordable and scalable solution for tasks like customer service and inventory management. However, the use of LLMs must comply with data protection regulations like the General Data Protection Regulation, GDPR, in Europe. Jeff Bezos, the founder of Amazon, has been a proponent of using advanced technologies to revolutionize retail. LLMs can also assist in logistics and supply chain management, optimizing routes and reducing operational costs. User experience, UX, design can be improved through A/B testing and user feedback, analyzed by LLMs. Loyalty programs can be personalized using LLM algorithms, offering targeted rewards and incentives. Augmented reality, AR, experiences, such as virtual try-ons, can be enhanced with LLM-generated content and recommendations. As consumers increasingly demand sustainability, LLMs can analyze product life cycles and suggest more sustainable practices. Overall, LLMs offer a transformative impact on the retail and e-commerce sectors, from customer experience to operational efficiency. Chapter 4: Automotive Industry. The automotive industry is another sector where LLMs are finding a range of applications. According to McKinsey, AI technologies could create a value of over $215 billion in automotive manufacturing and supply chain management by 2025. LLMs can assist in the design process by analyzing customer preferences and market trends. In manufacturing, they can monitor equipment and predict maintenance needs, reducing downtime. Customer service bots can handle queries about car features, pricing, and availability. LLMs can be integrated into in-car systems to offer voice-controlled functionalities like navigation and entertainment. They can assist in data analysis for autonomous vehicles, interpreting sensor data and making real-time decisions. Companies like Tesla are already using machine learning algorithms, although not specifically LLMs, to improve autonomous driving capabilities. LLMs can also be used in marketing campaigns, generating content that highlights a car's features and advantages. In the used car market, LLMs can analyze data from multiple sources to determine fair pricing. Elon Musk, CEO of Tesla, has expressed both excitement and caution about the rapid advancements in AI and machine learning. LLMs can assist in compliance by ensuring that vehicles meet safety and environmental regulations in different markets. They can also be used in training programs for automotive engineers and technicians. The integration of LLMs with other technologies like augmented reality, AR, can offer innovative solutions for both manufacturing and customer experience. LLMs can analyze customer reviews and feedback to identify common issues or areas for improvement. They can also assist in crisis management by monitoring social media and news for any brand-related incidents. In the emerging field of electric vehicles, EVs, LLMs can offer insights into customer concerns like range anxiety and charging infrastructure. Partnerships between tech companies and automotive manufacturers are likely to accelerate the adoption of LLMs in the industry. As with other industries, ethical considerations like data privacy and job displacement are important when implementing LLMs. In conclusion, the automotive industry stands to gain significantly from the capabilities offered by LLMs, from design and manufacturing to customer engagement and after-sales service. Chapter 5: Energy Sector. The energy sector is another area where LLMs are poised to make a transformative impact. According to a report by Swire, the global AI in the energy market is expected to reach $19.8 billion by 2031. LLMs can assist in optimizing energy production, analyzing factors like weather conditions and equipment efficiency. In renewable energy, they can forecast energy production based on environmental variables like wind speed or solar radiation. Customer service bots can handle billing queries, outage reports, and even offer energy-saving tips. LLMs can assist in predictive maintenance for energy infrastructure, reducing downtime and improving safety. They can also analyze energy consumption patterns, helping utilities and consumers make more informed decisions. Energy companies are using machine learning to improve the efficiency of wind turbines. LLMs can be used in regulatory compliance, ensuring that energy operations meet environmental and safety standards. They can also assist in emergency response, coordinating efforts during outages or natural disasters. Elon Musk, known for his work in renewable energy with Tesla's solar products, has been a prominent advocate for the responsible use of AI in various sectors, including energy. LLMs can analyze geological data for resource exploration, potentially finding new energy reserves. They can assist in the transition to smart grids, optimizing energy distribution and reducing waste. In the oil and gas industry, LLMs can analyze seismic data to improve the accuracy of drilling operations. LLMs can be integrated into building management systems to optimize energy usage, a concept known as smart buildings. As climate change becomes a more pressing issue, LLMs can analyze global data to propose sustainable energy solutions. They can also assist in public relations, creating content that educates the public on energy issues and the company's initiatives. Partnerships between energy companies and tech firms are likely to accelerate the adoption of LLMs and other AI technologies in the sector. As with other industries, considerations around data security and job displacement are critical when implementing LLMs. Overall, the energy sector offers a wide array of opportunities for LLMs to contribute, from operational efficiency to sustainability efforts. Thanks for watching. Part 4, Challenges and Limitations. Chapter 1, Accuracy and Reliability. While LLMs offer numerous benefits, concerns about their accuracy and reliability remain paramount. According to OpenAI, even state-of-the-art models like GPT-3 have a non-trivial error rate, which can be problematic in critical applications. The phenomenon of hallucination, where the model generates factually incorrect or nonsensical information, is a known issue. Fine-tuning and constant updates are essential for maintaining the accuracy of LLMs in specific applications. Businesses must implement strong validation processes to review and confirm the output generated by LLMs. In healthcare and finance, even minor errors can have significant repercussions, making human oversight indispensable. The black box nature of neural networks makes it difficult to understand the reasoning behind the model's decisions. Companies like Google are investing in explainable AI to address this issue, but it remains an area of active research. Verification mechanisms, such as checksums and digital signatures, can ensure the integrity of LLM-generated data. User feedback is a valuable resource for improving the reliability of LLM services over time. Probabilistic models, which provide confidence intervals for their predictions, are being explored as a solution to the accuracy problem. Dr. Feifei Li, a leading AI researcher, has emphasized the importance of integrating human expertise to improve model reliability. In mission-critical applications like autonomous driving or medical diagnosis, LLMs should only serve as an aid to human decision-making. The balance between model complexity and computational efficiency is another challenge in maintaining accuracy. The integration of LLMs with other verification technologies, like blockchain, could offer more secure and reliable systems. Real-time monitoring and alert mechanisms can help in quickly identifying and rectifying errors. Academic and industry partnerships are crucial for developing standards and best practices in ensuring LLM reliability. Public and peer reviews of LLM applications can offer additional layers of scrutiny and validation. The liability associated with LLM errors is still a gray area, requiring legal frameworks to clearly define responsibilities. In summary, while LLMs offer unprecedented capabilities, ensuring their accuracy and reliability is crucial for widespread adoption. Chapter 2, Ethical and Social Implications. The ethical and social implications of LLMs are complex and multifaceted. Issues of bias in machine learning models have received considerable attention, with instances where LLMs perpetuate gender, racial, or cultural biases. Companies like OpenAI and Google are actively working on research to mitigate such biases in their models. Ethical guidelines, such as those proposed by the Partnership on AI, aim to set industry standards for responsible AI use. Transparency in data sourcing and model training is crucial for assessing the ethical integrity of an LLM. In content generation applications, the potential for plagiarism or copyright infringement presents a significant ethical challenge. The potential misuse of LLMs for generating fake news, spam, or malicious content is another ethical concern. Regulatory frameworks, like the EU's proposed Artificial Intelligence Act, aim to govern high-risk AI applications, including LLMs. Public perception and trust are vital for the successful implementation of LLMs in societal institutions. Privacy concerns, especially in applications involving personal or sensitive data, require rigorous ethical considerations. The democratization of AI, ensuring equitable access to LLM technologies, is a subject of ongoing debate. Human-in-the-loop (HITL) systems, where human judgment complements machine predictions, offer an ethical model for LLM deployment. Ethical AI is an interdisciplinary field, requiring contributions from technology, social sciences, and humanities. LLMs can also be part of the solution by assisting in ethical analysis, auditing, and monitoring. Public consultations and ethical review boards can offer additional layers of ethical scrutiny. The potential for job displacement due to automation is a social concern that must be proactively managed. Education and reskilling programs can mitigate some of the social impacts of widespread LLM adoption. Ethical considerations are not static and will evolve as LLM technology advances and finds new applications. In summary, The ethical and social implications of LLMs are critical considerations for both developers and end users, requiring continuous vigilance and adaptation. Chapter 3: Data Privacy and Security. Data privacy and security are critical challenges in the deployment of LLMs across various industries. According to Cybersecurity Ventures, the global damage costs due to cybercrime are expected to reach $6 trillion annually by 2021. LLMs often require vast amounts of data for training, raising concerns about data ownership and consent. Regulations like the General Data Protection Regulation, GDPR, in Europe set stringent rules for data collection and usage. Data encryption and secure transmission protocols are essential for protecting sensitive information processed by LLMs. Businesses must adhere to industry-specific compliance standards, such as the Payment Card Industry Data Security Standard, PCI DSS, in finance. Anonymization and differential privacy techniques can be used to protect individual identities in large datasets. Bruce Schneier, a renowned security expert, has advocated for strong security measures in AI and machine learning systems. Cloud-based LLM services must guarantee robust security infrastructure to protect against data breaches. The rise of quantum computing poses a potential future threat to current encryption methods, requiring ongoing research into quantum-safe security. Auditing mechanisms should be in place to track data access and modifications, ensuring accountability. Businesses must have contingency plans, such as data backups and emergency response teams, for potential security incidents. Two-factor authentication, 2FA, and biometric verifications can add an extra layer of security for LLM access. The potential for insider threats, where employees misuse their access to LLM systems, is another security concern. Companies can employ security operations centers, SOCs, to monitor real-time data flow and potential security threats. Ethical hackers and penetration tests can help identify vulnerabilities in the LLM infrastructure. Open-source LLMs should be carefully vetted for security issues before being adopted in business applications. Industry collaborations, such as the Cybersecurity Tech Accord, aim to improve the overall security posture of technology products, including LLMs. Security considerations should be integrated into the entire lifecycle of LLMs, from development to deployment and maintenance. In summary, data privacy and security are indispensable aspects of LLM implementation and require rigorous planning and execution. Chapter 4: Computational and Environmental Costs. The computational and environmental costs associated with training and deploying LLMs are significant challenges. According to a study by OpenAI, the computational power needed for AI research has been doubling approximately every 3.4 months since 2012. The energy consumption of data centers running large models contributes to carbon emissions, raising environmental concerns. Companies like Google have committed to using renewable energy for their data centers to mitigate this impact. The concept of green AI, which aims to develop more energy-efficient algorithms, is gaining traction. Businesses must consider the total cost of ownership, TCO, which includes not just the model but also the infrastructure needed to support it. LLMs trained on specialized hardware like graphics processing units, GPUs, or tensor processing units, TPUs, can be more efficient but also more costly. Edge computing, where some data processing is done locally, can reduce the computational load on central servers. Techniques like model pruning and quantization can make LLMs more efficient without significantly compromising performance. Industry partnerships can help share the computational burden and reduce individual costs. Monitoring tools should be employed to keep track of resource usage and identify potential areas for optimization. Bill Gates, a prominent figure in technology and philanthropy, has stressed the importance of addressing the environmental impact of emerging technologies. Carbon offset programs can provide a temporary solution, but long-term sustainability should be the ultimate goal. The rise of decentralized computing models, like blockchain, poses both opportunities and challenges for LLM efficiency. Funding for research into more efficient machine learning algorithms can come from both public and private sectors. Life cycle assessments that consider the environmental impact of LLMs from creation to retirement are essential. The cost of data storage is another consideration, especially as LLMs often require large datasets for training. Adaptability and scalability of the computational infrastructure are crucial for accommodating future advancements in LLM technology. Businesses should factor in the operational costs, including energy consumption, when calculating the return on investment, ROI, for LLM projects. In summary, the computational and environmental costs of LLMs are significant challenges that require multifaceted strategies to address. Chapter 5: Legal and Regulatory Challenges. The legal landscape surrounding LLMs is complex and often lagging behind the rapid advancements in technology. Intellectual property, IP, issues arise when LLMs generate content, raising questions about originality and copyright. In the United States, the Computer Fraud and Abuse Act, CFAA, is one of the primary laws governing unauthorized access to computer systems, including LLMs. Data sovereignty, the concept that data is subject to the laws of the country in which it is located, complicates international deployments of LLMs. Liability questions emerge when an LLM's output leads to financial loss or harm. Determining accountability can be challenging. The European Union's proposed Artificial Intelligence Act aims to regulate high-risk AI applications, which could include certain uses of LLMs. In healthcare, the U.S. Food and Drug Administration, FDA, has guidelines for software as a medical device, which could extend to medical applications of LLMs. Legal scholars have emphasized the role of regulation in shaping the development and impact of technology. User agreements and terms of service must clearly outline the limitations and responsibilities associated with using LLMs. Data protection officers, DPOs, can help businesses navigate the complex web of privacy laws applicable to LLM data. Ethical considerations often precede legal ones. Businesses should aim for ethical compliance even when legal guidelines are unclear. Open source LLMs present a unique set of challenges, including the potential for misuse and the difficulty of enforcing compliance. Industry self-regulation, through bodies like the Partnership on AI, can complement governmental regulations. Consumer protection laws, such as the U.S. Federal Trade Commission Act, can apply to misleading or false claims made by LLMs. Businesses need to be aware of export control laws if they plan to deploy LLMs internationally, especially in sensitive sectors like aerospace. Accessibility standards, such as the Americans with Disabilities Act, ADA, may require LLM interfaces to be accessible to people with disabilities. Legal frameworks should adapt to consider the collective intelligence of LLMs and humans, rather than treating them as separate entities. Ongoing legal education and awareness are essential for both developers and users of LLMs. Public discourse and legislative action should evolve in tandem to address the unique challenges posed by LLMs. In summary, the legal and regulatory landscape for LLMs is a complex but crucial aspect of their broader adoption, requiring vigilance and proactive management from all stakeholders. Thanks for watching. Part 5, The Future of Large Language Models. Chapter 1, Technological Advancements. Technological progress in the field of LLMs is both rapid and relentless. GPT-4, the successor to GPT-3, offers even greater accuracy and capabilities, showcasing the fast-paced evolution. Quantum computing holds the promise of supercharging machine learning algorithms, potentially revolutionizing LLMs. Research into multimodal models, capable of processing text, images, and even sound, is a hot topic. The concept of green AI aims to make the computational process more sustainable, aligning with global climate goals. Transfer learning allows models to adapt quickly to new tasks, increasing the versatility of LLMs. Decentralized AI and blockchain technology offer new paradigms for data privacy and security. The intersection of LLMs with augmented reality, AR, and virtual reality, VR, offers unprecedented interactive experiences. Edge computing is gaining attention, enabling real-time data processing locally to reduce latency. Geoffrey Hinton, a pioneer in deep learning, predicts that unsupervised learning methods could unlock new potential in LLMs. Advanced hardware like new generations of GPUs and TPUs will make LLMs more efficient and cost-effective. The advent of 5G will facilitate real-time applications, from autonomous driving to telemedicine. Neural symbolic integration, combining neural networks with traditional symbolic AI, is an emerging area. Open source initiatives continue to democratize LLM technology, making it accessible to a broader audience. Universal translators, built on LLMs, could break down language barriers, fostering global unity. Research is ongoing into lifelong learning models, which adapt and evolve without needing to be retrained. Human-AI collaboration tools will become increasingly sophisticated, enhancing both productivity and decision-making. Ethical AI frameworks, including transparency and fairness, will continue to be a major research focus. Investment in AI is surging, with forecasts suggesting a global AI market size of up to $15.7 trillion by 2030. Emerging LLMs like Eleuther AI's GPT-J and Google's Lambda 2 and Bard are pushing boundaries in specific domains like conversational depth and context understanding. Conversational agents are expected to become more empathetic and context-aware, thanks to advances in sentiment analysis. Language translation capabilities will improve, making real-time, high-quality translation a standard feature. Data-efficient training methods are being researched to make LLMs more accessible for smaller organizations. The integration of LLMs into robotic systems could lead to more natural human-robot interactions. Attention mechanisms in neural networks will evolve, allowing LLMs to better focus on relevant information in large datasets. The development of self-supervised learning techniques could lessen the dependence on large labeled datasets for training. Real-time analytics and feedback loops will become integrated features, enabling LLMs to adapt and improve during operation. Research into the common sense understanding for LLMs aims to make them more intuitive and reliable. The concept of AI safety, ensuring that AI systems behave predictably and safely, will be central to future LLM developments. In summary, technological advancements will make future LLMs more capable, efficient, and integrated into our daily lives. Chapter 2: Economic Impact. The economic landscape is poised for transformation as LLMs become more ubiquitous. McKinsey & Company estimates that AI could add as much as $13 trillion to the global economy by 2030. Customer service is one sector where LLMs are already reducing labor costs and enhancing efficiency. The gig economy stands to benefit immensely, offering freelancers robust tools for content generation, data analysis, and more. Job displacement due to automation is a concern, particularly for lower-skilled jobs. Reskilling and upskilling programs are crucial for preparing the workforce for an automated future. Data is the new oil, and its economic value is set to increase given its role in training LLMs. Global trade will likely include a growing sector dedicated to AI technologies, including LLMs. Small and medium-sized enterprises, SMEs, can leverage LLMs to compete with larger corporations. Andrew Ng, an AI pioneer, likens AI's economic impact to that of electricity, anticipating widespread transformation. Countries investing heavily in AI infrastructure will likely gain a competitive edge on the global stage. Economic inclusivity can be promoted through LLMs by offering affordable services to underserved communities. New business models for LLMs are emerging, from subscription-based to data monetization strategies. Public-private partnerships can help accelerate the adoption and economic benefits of LLMs in sectors like healthcare and education. Niche markets for specialized LLMs are likely to proliferate, serving specific industries and applications. Economic policies will need to adapt to the challenges and opportunities presented by the rise of LLMs. Venture capital investment in LLM startups and AI initiatives will likely see significant growth. New taxation models could emerge to accommodate the economic transformations brought about by automation and AI. Countries with advanced AI capabilities may gain increased economic and geopolitical influence. Economic indicators will need to be developed to measure the impact of LLMs accurately. The shift toward remote work, facilitated by LLMs, could have long-term economic implications, including changes in real estate and commuting. LLMs could assist in fraud detection and risk assessment in the financial sector, potentially saving billions annually. Intellectual property laws will need updating to account for content generated by LLMs. Economic simulations run by LLMs could provide unprecedented insights into market trends and risks. LLMs can streamline supply chain management, reducing costs and increasing efficiency. The economics of cloud computing will evolve as more businesses rely on cloud-hosted LLM services. Pay-per-use or tiered subscription models may become prevalent for accessing high-end LLM services. The economic impact of LLMs on traditional publishing and journalism is a developing area of study. Automation in data analytics, powered by LLMs, could provide businesses with real-time insights, affecting decision-making cycles. In summary, the economic impact of LLMs will be transformative, influencing labor markets, global trade, and economic policies. Chapter 3: Societal and Cultural Influence. The societal and cultural ramifications of LLMs extend far beyond economics and technology. Democratization of information through LLMs has the potential to bring about significant societal change. However, there's a risk of amplifying social biases and inequalities if LLMs are not carefully designed and deployed. Education is a sector where LLMs could bring about a revolution, offering personalized learning experiences. Journalism and media will see both challenges and opportunities, from automating news reporting to the creation of deepfakes. The potential to shape or manipulate public opinion through LLM-generated content is a critical ethical concern. LLMs could be instrumental in cultural preservation by digitizing, translating, and interpreting rare or ancient texts. Noam Chomsky, an influential linguist and philosopher, has been a strong voice in discussing the role of technology in shaping human communication. LLMs could become tools for social justice by automating the analysis of legal and public records. The digital divide may be exacerbated as LLMs become more advanced, leaving behind those without access to technology. Social norms related to human-machine interaction will inevitably evolve as LLMs become more integrated into daily life. Mental health services could benefit from LLMs as supplementary support, though ethical considerations are paramount. Platforms like social media could undergo a transformation with the integration of LLMs for content moderation and generation. The creative fields, including art, music, and literature, will also be influenced by the capabilities of LLMs. The definition of authorship and creativity may need to be re-evaluated in the age of machine-generated content. In crisis management, LLMs could help by analyzing vast amounts of data quickly to inform emergency responses. Public discourse and policymaking could be enhanced with LLMs capable of summarizing complex documents and simulating potential outcomes. LLMs could be used to foster community engagement, enabling more efficient and inclusive communication. Questions surrounding identity and privacy will become more complex as LLMs gain the ability to generate increasingly personalized content. Ethical and societal considerations will guide the development and deployment of LLMs in sensitive areas like healthcare and law enforcement. LLMs could assist NGOs and humanitarian organizations by automating administrative tasks and data analysis. Public sentiment analysis, made possible by LLMs, could provide governments with valuable insights into the effectiveness of their policies. LLMs have the potential to revolutionize accessibility services, offering real-time translation and transcription. Ethical considerations will be paramount when deploying LLMs in settings that involve vulnerable populations, such as children or the elderly. The cultural implications of LLMs in entertainment, including gaming and film, are expansive. Linguistic diversity and the preservation of lesser-known languages could be aided by specialized LLMs. Interdisciplinary research involving sociologists, ethicists, and technologists will be crucial to understanding the societal impact of LLMs. LLMs could play a role in combating misinformation by providing real-time fact-checking services. The growth of LLMs in the developing world could be a catalyst for social and economic change. In summary, LLMs have the potential to significantly influence society and culture, raising both opportunities and ethical considerations. Chapter 4: Ethical and Moral Questions for the Future. As LLMs become more advanced, the ethical landscape surrounding them is bound to become increasingly complex. Speculative questions around machine consciousness could gain prominence as LLMs become more sophisticated. The use of LLMs in law enforcement and surveillance raises serious ethical questions, especially concerning privacy and civil liberties. Ethical considerations in biotechnology, such as gene editing, could intersect with the capabilities of LLMs in data analysis. The role of LLMs in shaping public opinion, especially in democratic processes like elections, raises ethical concerns. Nick Bostrom, known for his work on existential risks, has highlighted the long-term ethical implications of artificial intelligence. Ethical standards for LLMs in warfare, including autonomous drones and cyber operations, are a subject of international debate. The risk of LLMs perpetuating systemic biases in fields like criminal justice is a critical ethical concern. Moral considerations in using LLMs for mental health services include the risks of misdiagnosis and inappropriate treatment. Social norms for machine behavior, similar to ethical guidelines, may need to be established as LLMs become more integrated into society. Regulatory bodies may evolve to include ethicists, technologists, and public representatives for more comprehensive oversight. The concept of informed consent will need to evolve as LLMs become capable of generating more personalized and sensitive content. Ethical hacking methods, including red teaming, could be vital for testing the ethical robustness of LLMs. Moral questions around data ownership and the ethical implications of monetizing user-generated content will continue to be relevant. The right to explanation, especially as LLMs replace human roles, will be increasingly important. The balance between personalization and privacy is a recurring ethical concern in the deployment of LLMs. Differing ethical frameworks across cultures and jurisdictions will pose challenges for the global deployment of LLM services. Future LLMs may include ethical circuit breakers to halt operations if ethical boundaries are crossed. Ethical guidelines for the role of LLMs in education will need to be established to ensure fairness and the well-being of students. The integration of ethics into AI and computer science education will likely become standard practice. Debates around the ethical considerations of deepfakes and synthetic media generated by LLMs are gaining traction. Research ethics, especially concerning data collection and user consent, will be crucial in the development of more advanced LLMs. The ethical implications of LLMs in healthcare, especially concerning patient confidentiality and data security, require careful scrutiny. Consumer protection laws will need to evolve to account for the capabilities and potential risks of LLMs. The role of LLMs in emergency response and disaster management raises ethical questions about accountability and reliability. Ethical considerations will be crucial when deploying LLMs in settings that involve vulnerable populations, such as children or the elderly. Open dialogue among stakeholders, including the public, is essential for the ethical development and deployment of LLMs. The accessibility of LLMs to people with disabilities is an important ethical consideration that aligns with broader social inclusion goals. Transparency in how LLMs make decisions, including the algorithms that power them, will be critical for ethical compliance. In summary, the ethical and moral dimensions of LLMs are complex, evolving, and will require ongoing scrutiny from all stakeholders. Chapter 5, Conclusion and Outlook. LLMs sit at the intersection of technology, economics, ethics, and society, and are poised to redefine various facets of human life. Interdisciplinary collaboration will be essential for the responsible and beneficial development of LLMs. The journey from rudimentary, rule-based systems to advanced models like GPT-4 marks just the beginning of what is possible. The economic implications, though promising, need to be balanced against ethical considerations and societal impacts. Marvin Minsky, an AI pioneer, described AI as a science that makes machines capable of tasks requiring human intelligence. Specialization will be a hallmark of future LLMs, tailored for distinct applications across different industries. Advances in edge computing and IoT devices will lead to the ubiquity of smart environments enhanced by LLMs. Human expertise will continue to be invaluable for guiding, validating, and interpreting the operations of LLMs. Public engagement in the discourse around LLMs is crucial for democratic governance and ethical development. Regulatory frameworks will evolve to incorporate AI and LLMs, especially in areas like legal interpretation and compliance. Environmental sustainability will be a key consideration, affecting both the computational efficiency and broader ecological impact of LLMs. The next decade will be a defining period for LLMs, both in terms of technological advancement and societal impact. Ongoing research into AI explainability will make future LLMs more understandable and accountable. Ethical education in AI will likely become a component of standard curricula in computer science and engineering programs. The dual-use nature of LLMs, for both benefit and harm, necessitates vigilant and responsible management. As AI becomes more integrated into regulatory frameworks, LLMs could assist in legal interpretation and compliance. The balance between achieving advanced capabilities and ensuring ethical and safe operations will be a continuous challenge. Innovations in hardware technologies, such as quantum computing and neuromorphic chips, will influence future LLMs. As LLMs evolve, so too will the challenges, from technical limitations to ethical dilemmas. Research into making LLMs more transparent and understandable will remain a significant focus. LLMs are likely to become more context-aware, enhancing their usability and reliability across various applications. The integration of LLMs with other emerging technologies, like blockchain and AR/VR, will create new paradigms of interaction and utility. As LLMs become more capable, the lines between human-generated and machine-generated content will increasingly blur. Public-private partnerships will play a crucial role in steering the development and application of LLMs in a socially beneficial direction. Open-source models will continue to be significant for the democratization of LLM technology, although they present unique challenges. The role of LLMs in global challenges, from climate change to public health, will be an area of focus. The ethical and societal questions that LLMs raise will require a multifaceted approach to governance. Investment in AI ethics and safety research will be crucial for the long-term sustainability of LLMs. LLMs will continue to evolve, influenced by scientific discoveries, market forces, societal needs, and ethical guidelines. In conclusion, LLMs represent a frontier in human-machine collaboration, promising to shape a future that aligns with our highest aspirations and most diligent precautions. Thanks for watching.